Right, to understand the traffic engineering, we have 7 routers, and I'm going to do most of the basic configuration with the help of Notepad, and anything related to traffic engineering, I'll do it separately. So for router 1 is like a customer edge router. Enable OpenFT interface playback 0, IP address 1.1.1.1, 255.255.255. Interface, I think the name of this interface is 0, no shared IP address 13.0.0.1, and we are not going to run any routing protocol as we discussed earlier. So I'll say IP route any network, any subnet mask, send it to router 3, which is 13.0.0.3. There is no other configuration needed on the customer. So copy all this and paste it over router 1. Now on router 2, it's going to be 2.2.2 here, and this will be 42.2, and I have default route to 42.4. No other configuration needed. I'll copy and paste it on router 2. Router 2 is also. Now you remember R3 and R4 are PE routers. Let me draw a box. Provider edge routers. So we will have VRFs. A VRF for this customer. I'll create a VRF called C, and I'll put this interface in the VRF. And here inside the IGP, I'll run an IGP inside the core. IGP will be OSPF. I'll run OSPF area 0, and then I'll run IBGP. On top of it, I'll enable MPBGP. Before that, I'll have MPLS in the core. So let's see how to do that. I'll start with router 3's configuration. On router 3, the loopback address will be 3.3.3.3. I need to run OSPF here, so I'll say IP OSPF process ID 1 area 0, and we got 0/1 interface, which is the provider facing interface, that has got 10.35.3, and it will be 255.255, and we don't have a default route, instead we have OSPF. Then now for the customer IPVRF, I'll give a name C, route distinguisher 1:1, route target, I'll say also 1:1, and then I'll go inside the interface. I go inside the interface 0/0, which is customer facing interface. I'll go inside and then I'll apply the interface to, I'll put the interface to a VRF. The VRF is IP VRF forwarding C, no shutdown, and the IP address will be 13.0, and it will be this. So VRF is also done. Next is BGP. router BGP 100. We are going to form IBGP between 3 and 2. So before BGP, you remember we have static route between the customer and the provider edge. So for the customer's network from the provider, I have this IP route VRF C 1.1.1.1 1.1.1.1 255 or 245 or 245 or 245 send it to 13.0.0.1. So customer's network has to be reachable from here. So I am writing a static route. Next is router BGP. I'll say neighbor is 4.4.4.4. Remote autonomous system is 100. And to the same neighbor, update source loopback 0. And I also want to activate the neighbor under VPN. So address family VPN v4 unicast and activate this neighbor. Next is what we need to take the customer route, the static route, and put it into the VPN. So the command will be address family IPv4 VRF C redistribute static. Is there any doubt up to this level? I'm just going to paste this. Can I take it as no? MPLS IP MPLS IP. Right, so this is the configuration for router 1. I'll copy this and paste it on router 1. When I paste it, I need to be, so not router 1, router 3. I need to be very careful. I need to look for any errors. Loopback is okay, OSP is given. MPLS not supported on interface loopback, okay, no problem. I don't think there is an error. Let's verify one more time. What I want to check is, I want to check first the IP address, show IP interface brief. I see that 13.3 is on F00 and 10.34.0.3 is on F01, and loopback has got this. And I want to check the OSPF, show IP OSPF interface brief. I see that loopback and the provider facing interface, provider core facing interface, they're running OSPF. And I want to check whether VRF is proper. So show IP VRF. I can see that there is a VRF called C and the interface 0 has been assigned to it. Right, good. Next is I want to check MPLS, show MPLS interfaces. I see that MPLS is running on this provider's interface. That's perfect. Now let's go back to router 2 and solve the problem. See, this is the mistake that I have done on the default route. I'll change the default route. Mistake, instead of 42, given 43. Alright, so next is what I need to go and verify. One more verification from R3. Ping using VRFC 1.1.1.1. I must be able to ping through the static routes. Right. Now let us finish router 4 configuration. Router 4, not much difference. On router 4 I have loopback interface with 4.4.4.4 and OSPF will be running there. And MPLS is in the global mode actually. Global mode MPLS IP. And then interface 1/1/0 will be running MPLS, and that will have 10.74 74.4 and OSPF must be there, and this is not a member of. Okay, this is creating VRF. It's creating VRF, and the VRF, let it be same. And the interface name is F0/1 IPVRF forwarding C. The IP address will not be 13, instead it will be 42.4. And then static route should be for 2.2.2.2 42. BGP is between router 4 and router 3. Okay, so what is next? I don't think so. Everything is done. Let's paste this. Router 4. Okay. Now I'd like to ping and verify. Ping using VRFC 2.2.2.2. It's pinging. So one more show IP MPLS. Show MPLS interface. It is there. Alright. Show IP OSPF interface. Alright. So provider interface and then the loopback interface. Now the other three routers are very simple. We don't have BGP, so I cut the BGP out. And then we don't have VRF, so no VRF. No VRF. And we do have loopback, so this is for router 5. I'll say 5.5.5, and MPLS will be running everywhere. F0/0 will have 10.35.0.5. I'll copy this and then I'll delete all this. Okay, so one more time we have 0/1 will have 57.5 and 1/0 they all run OSPF, they all run MPLS. 1/0 will have 56. Alright, so no other. Then this is for router 5. I paste it. So what do I expect here? One OSPF neighbor and one MPLS neighbor. OSPF is done. I can see 3.3.3.3. Next is MPLS. I would like to see MPLS is also there. LDP neighbor 3.3.3.3. Let's finish router 7. Similar number of interfaces. Router 7 loopback will be 7.7.7.7 and fast internet 00 will be 57.7 and 01 will be 74.7 and 10 will be 67.7. That's all. Now I'll copy and paste this. So, one last router. 6.6.6.6. F00 will have 10.56.6. F.01 will have 67.6. The other interface we don't have, so I remove this. This is on router 6. So what I expect from R6 is I should see two neighbors, two MPLS neighbor and two OSPF neighbor. Right, two OSPF neighbor and two OSPF neighbor is called MPLS. Yes, two MPLS neighbor is called. Now for the verification, what we'll do is we'll go to router 3 and we have already redistributed and VPN is up and working. I can see that from R3 now. You see, there are two BGPs. One is, no, let's check it. Show IP BGP summary. I can see BGP. Show BGP VPN v4 VRF VPN v4 unicast all summary. I can see even here via VPN it has learned a prefix, which means I can ping from router 1 to router 2. Ping 2.2.2.2 is the source of wonder. It is pinging. So your VPN, MPLS VPN is good. I'd like to trace route and see now. So I can see that the MPLS is working and I can see two labels. Traffics are going from 5 to 7. Traffics are going to 5 to from 5 to 7. It is bypassing 6. It's not going through 6. So what we will do is, in order to check the other route, we'll give the IGP cost, more IGP cost between 5 and 7 so that path will be preferred via router 6. Between router 5 and 7, interface here 0/1, IP OSPF cost 65535, the highest cost. And our R7 interface here 0/0, IP OSPF cost 65535. Now the cost is different. It's not a default cost, it's the highest cost. This time when I trace route, it should not go to 7 from 5. I'll have one more hop. I'll have 6 hops. Right now I have only 5 hops. Because I changed the metric, this time when when I trace route, it should have 6 hop, and packet will go from 5 to 6 and 6 to 7. 3, 5, and 6. Look at this. 7, 4, and 2. So this is a long route. But assume that IGP's best path is via 6. Assume IGP's best path is via 6. Path between 5 and 7 is always idle. It's not at all in use. I can run MPLS traffic engineering to make use of this path. Optimum utilization. Instead of sending all the traffic via that single path, I can also send some important traffic using this idle path, the path between 5 and 7. So now what I'm going to do is I'm going to take this customer's route coming from 111 going to 222. I'm going to put those route via this route, like bypassing 6. Right now when I trace route, it goes via 6. But after I finish my traffic engineering, it should go via 5 to 7 bypassing 6. So let's enable traffic engineering. You know that there is a common command to be given on every device called MPLS traffic engineering tunnels. And also we need to enable IGP protocol called constraint based SPF algorithm, CSPF, constraint shortest path first. I run OSPF, so I go to OSPF, router OSPF process ID, and I say MPLS traffic engineering area 0 and MPLS traffic engineering router ID is loopback 0. So this is the loopback address that MPLS uses as the router ID. Also OSPF uses as the router ID. Even BGP uses as the router ID. So I use the same thing here for MPLS traffic engineering. So next thing, this is mandatory. What is next is I need to enable MPLS globally, MPLS traffic engineering channel, and also I need to go to the interface F0/1 and enable the same traffic engineering command and the RSVP command. RSVP, as we know, it's a protocol that helps to reserve the path that has got adequate bandwidth for your equipment. And I need to say this command IP RSVP bandwidth. You know that if I didn't mention the bandwidth, the amount of bandwidth that this can utilize, it's going to consume 75% of the existing bandwidth of the total bandwidth of the interface. So if you want to have your own prescribed bandwidth, you can use that. It is in kilobits. You can give in meg. You can give in kilobits. It will convert into meg and take it. If you don't provide the bandwidth, then it is going to be 75%. These things we have already seen in the theory class. Do show history. Right. These comments, I'm going to take it to the notepad and paste it on all the routers. Enable config T. So on router 4, how it will go? On router 4, it will be 0 here. There is no other change. I copy this and I paste it on router 4. Right. Next is on router 6, we have 2 interface, and router 5 we have 3 interface. F1/0 and 0/1. Done. There is no other change to be done. This is common command on all the routers. I copy this and I paste it on router 5. Similarly on router 7, same number of interfaces. On router 6 we have only 2 interfaces. So on router 6 I cut this alone, not necessary. Copy and I paste it on router 6. Now MPLS traffic engineering is enabled on all the device. Now you can see, if you want, you can see the topology, MPLS topology. Show MPLS traffic engineering topology. I can see the topology. See, it shows all the routers in the path. It shows router 7, it shows router 4, it shows router 6, and it shows every one, 5, every one, not only directly connected router. It shows everyone, you see. 10.67.0.7, the neighbor node. 74.0.0.4. It is not direct neighbor, but traffic engineering is running there, right? So it's a very big list, you can see later. And there is also another command, brief command, but it is not really brief, it's almost the same. I can see the router ID to which it has got the associations 3, 5, 7, 6. So this is one command, show MPLS traffic engineering topology and topology brief. It's like show IP OSP of database. It's like a OSP of database. Here it is, traffic engineering database. You can see this on every router. Now what we are trying to achieve is, whenever I trace route from router 1, router 6 should be bypassed. Router 6. Going via router 6 is not the preferred path for me. It's the IGP's path. It's IGP's preferred path. It's not the preferred path according to our policy. According to our policy, the preferred path is going from 5 to 7 directly by bypassing 6. So where is the tunnel head? Tunnel head is on router 3. Because traffic is going from R1 to R2. I want to remind you something. Traffic engineering tunnels are unidirectional. When traffic going from R1, I want to send it directly from 5 to 7. But that is not the guaranteed one when I go from 2 to 1. When I go from 2 to 1, it will take the path via 6. The IGP path. Why? Because it is it's a unidirectional. So we have enabled traffic engineering on all the device, but as I reminded you, let me repeat it one more time. MPLS traffic engineering is unidirectional. So traffic from 1 to 2, it will take the paths that you are going to prescribe through traffic engineering. But the traffic from 2 to 1 will not take the same path. We cannot expect it to take the same path. It will take the IGP's preferred path. So now let us go to the head end of the traffic engineering tunnel, which is R3. Because you are pinging from R1, R3 is a tunnel head. So on the tunnel head, I need to create the interface tunnel 0. Interface tunnel 0. Tunnel mode is MPLS traffic engineering. Tunnel mode, same like a GRE tunnel. IP unicast, the configurations are same like GRE. IP unicast loopback 0. This is also mandatory. You need to use the same interface that is defined as a router ID for traffic engineering. You remember under OSPF you gave router ID loopback 0. So it should be the same interface here under the tunnel 0. So what we are saying here is we are asking tunnel 0 to use the loopback interface address as the address for this interface. That's the command. Now, tunnel destination. Tunnel destination is router 4, footer 4. And I'll keep this interface shut down for some time. I'll bring it up later. And then tunnel MPLS traffic engineering. You see, you have a lot of options. And what I want is the path option. The path option, you have a dynamic. Okay, path option. If I say path number 2, which means if I will have another path with path number 1, that path will be first preferred and this path will be second preferred. I'm saying path 2 is dynamic. So I'm saying path 2 option is dynamic, which means I can have path 1, which is an explicit path. I can have an explicit path. I need to give the name of the explicit path. So, explicit path is like for us, explicit path is to go via router 5 to 7. From 5, it should not go to 6, it should go from 5 directly to 7. That is what explicit path we want to have. But what is dynamic path? The path prescribed by the IGP protocols. So we don't want the explicit, the dynamic path. We want explicit path. So we have to first of all create the explicit path. So let's see IP MPLS IP explicit command. MPLS traffic engineering. Do I have path option? It is IP explicit path. IP explicit path. And I give a name for this explicit path. I'll give name as my preference. My preference. Name should be typed, and then my pref. Okay, here I need to say the path. I need to say next address. The next address. So we are starting from router 3. For router 3, from router 3, what is the next address? The next address is 5.5.5.5. Yeah. Enter. And then what is the next address from 5 where you want to go? You want to go to 7.7.7.7. Then see how nicely the next addresses are, next hops are mentioned here. And then again next, it's 4.4.4.4. That's it. So we got the hops via which the packet you want to send. And what's the name of this? The name of this is my pref. Now I'll go inside that interface tunnel 0. Tunnel MPLS traffic engineering. Path option 1. And we want explicit. And the name that we have is this one. That's all. Did you understand this? Do you have any doubt in this? So we define the path and we call the path. And because this number is smaller than the dynamic one is 2 we gave. I can take you one more time to the top and show you. The dynamic one, the path option is 2. And this is 1. The lowest one is preferred first. So now if I trace route from router 1 Yeah, look, the lowest one is the preferred one. I still see the packet is going where. Why? Someone tell me why. I understood why, but I want to see whether you also understand it. No, no, no. So we have not said like which traffic will be using this tunnel zero interface. You're creating tunnel zero interface, right, for traffic engineering. You need to say which traffic can use this tunnel. I need to say which traffic can use this tunnel. So let us do that by giving this command interface by giving a static route. I can run a IGP protocol on tunnel zero and the customer facing interface, but this is what practically seen. We write a static route, IP route, in order to go to 2.2.2.2, 255.255.255, send it via tunnel 0. Send it via tunnel, what is this? Tunnel 0. Right? Tunnel interface. Oh yeah, sorry. I was doing on the customer route which is wrong. You're right. I should do on router 3. So I say again IP route in order to go to 2.2.2.2, 255.255.255, go via tunnel 0. So here it is accepting because we have tunnel 0 here. On the other router where I was doing, we don't have any tunnel 0, so it was showing an error. Now, only when traffic goes to 2.2.2.2, traffic will go and kick the tunnel 0 interface, and tunnel 0 interface says go to 5, and from 5 to 7 you go. Don't go via 6. But your routing table says to go via 6. But MPLS traffic engineering preferred path says no, go via router 5 to 7 bypassing 6. Now let me trace route and show you. Going to 3, 5, oh no. Even now it is going to 6 and 7. What may be the mistaken thing? MPLS is a source based, right? Let me check. Let me go to 3, 3 and say show IP route. Show IP route. I put a static route here. There is no static. How come? Show IP interface 3. Oh, tunnel is down. Tunnel is not in use. Let us go and bring it up. Interface tunnel 0, no shut. But before saying no shutdown, I'm asking you a question. Did I configure tunnel on R4? That has to be done first. Do show run interface tunnel 0. I'll just copy all this and do slight alteration. Interface tunnel 0. We are not going to, okay, if you want to write a map for the return traffic, you can do it. So let us also do the explicit path configuration for the return traffic. So the commands will be this one. IP explicit path. If you want, you can do it. All right. If you want, you can do it. I'm going to do it for the return traffic. And I need to give the next stop address. So for the return traffic, I'm saying from here, from 4 you go to 7, and from 7 you go to 5. You want to give, then you no need to mention this. Okay, if you want to give 6, you can cut this one. You can cut this line, it will go as 6. Alright, so now let us paste this. What will be the address here? 3. I'll say no shutdown. Right, so here no shutdown is given and everything is configured. Let me also say no shutdown on router 3 to bring the tunnel interface up. No shut. Right, see the tunnel interface has come up, line protocol has come up. Now I'm expecting show MPLS traffic engineering tunnel. Okay, wonderful. I can see here see how beautifully it shows. I'll show it from the beginning on the top. R3 on R3 we have the tunnel and the destination is 4.4.4.4. It is up, administratively up, operationally up. It's a valid path and it is connected. This is a very good sign. And preferred path is explicit path mypref. If that has got some problem, then it will take the other path. And the next is the priority by default, it will give us 7. Affinity we have not set. Bandwidth we have not set. Traffic engineering type traffic metric. Right now, explicit path 1 is active because you have enough of bandwidth. We have not mentioned anything. And see this route it takes from 333 to 444. The tunnel instant how it goes from I can see 10.35.0.5 and 57.5 and 57.7. You see there is no 6 router involved here. It shows packet will go from here to here and from here to 7. It shows the path and then it shows router 4. Right? Okay. Now let us test it. Let's go to router 1 and trace route 5 6. Still it goes via 5 6 5 6. What the tunnel is up. Let us go to 4. Show traffic engineering. Show MPLS traffic engineering tunnels. What may be the reason why am I getting this? Going from 111 to 222. Did I give a static route on R3? Let me check R3 static route. Show MPLS, show IP route static. I can see that in order to go to 2 to 2, it will take tunnel 0 interface. If it takes tunnel 0 interface, it should pick up with the MPLS traffic engineering. And why am I not able to see the route? I think the testing place for what I'm doing, where I'm doing is the mistake. What I should do is I should test from R3 to R4. So I'm going to write this static route. You know, MPLS traffic engineering is for the customer route. I do agree, but who is switching the label from R3 to R4? It is normal MPLS. So I should not keep the customer's destination address here. I should give my other tunnel endpoint. So I'll say no here. The MPLS traffic engineering is for the service provider, not for the customer. But ultimately it takes the customer route. But from where to where? From PE to PE. So I should change this. IP route. Whenever it goes to 4.4.4.4, 255, it should use tunnel 0. This is how it should be. Now I'll say trace route 4.4.4.4 using source 3.3.3.3. I'm expecting 5 from 5 to 7. Wow, look at this. This is what I was telling you. It didn't take via 6. It goes via router 5 to 7 directly. It's not going via 6. If I remove the traffic engineering, if I remove the static route, you see what happens. I remove the static route. Now I trace the route. 5, 6. It goes via 6. When it tries to go via the tunnel says from 3 you go to 5, from 5 you go to 7. So let me put it back, the static route. Once I put the static route inside the tunnel, you will see again, see that even the label will differ. Label, this is normal label, not traffic engineering label. Traffic engineering will give a label and that label will be different. See, it's 23. Is there any doubt up to this level? Yeah, this is, yeah, it has taken the explicit path, correct. Now, if I do trace route from 4, 6, correct. If I say 3.3.3.3 with source of 4.4.4.4, it will not go via 7.5, it will go via 6. See, it takes the dynamic path. It's unidirectional, no? So, if you want R4 also to send from 7 to 5, we need to write an explicit path. If you want, I can write it quickly. IP explicit path. Name, I'll give us 4 to 3, 4 to 3, any name. And then the command is next address is 7.7.7.7. Again, next address is 5.5.5.5. And then again, next address is 3.3.3.3. After this, we will go to that interface tunnel 0 command, and then we will say tunnel MPLS traffic engineering, path option. We have number one still left for us. We use one, highly prioritized. Path option one, which is explicit, and the name is 423. I think this is what I gave. Yeah, 423. 423. Done. Now if I trace the route from 4, even the label should be different. See, let me show you the previous condition before traffic engineering. Explicit path. Before explicit path, it was going via router 6, and the label is 18, 19, 16. But now, again 18, 19, 16. What is the reason? What is left? 3G, what is left? What is the missing point? The static route. The static route. So I'll write a static route. I'll say IP route 3.3.3.3 255.255.255.255 go via 1000. Now if I say 7 to 5, wonderful, 5 to 3, and 3 to 3. Now if you shut down this port, it will go via option number 2. Let me show you that. I'll go to router 7, interface F0/0, I shut down. After I shut down, when I try the same thing, it should not go via 5, it should go via 6. It will take option number 2. Okay, convergence time. That's why it is showing like this. Okay, see, it goes to 6, 5, 3. Now when I say no shutdown, again it will be falling back to option number 1. Hey, wait a minute, I'll keep it shut down. And show you some verification. Show MPLS traffic engineering kernel. I should see that the path option 2 is active now. I want to see that word saying path option 2 is active. This is the explicit path. That's okay. Signaling is down. Let's speak. See, there's a path error. There's a path error in the explicit path. So signaling is down. It will fall to path number 2. I'm expecting path number 2, and they should come up. Because it is DNS, maybe it's not converging faster, but it should. See, path option is 2 now. The path option right now is 2. So if I trace route, it will go via 6, 7, and 6, and 5, and 3. Now when I say no shutdown on router 7, no shutdown, and going back to router 4 and checking the path option. No, not tunnel. The path, the explicit path, option number 2 path. So now I'm expecting this to take the path via router 1. the command is no problem. Show MPLS traffic engineering terms. Now I can see that the path option now should be via router 1. Sorry, path option 1. It should be via 1. Path option is unknown. Give some time for convergence. Okay, I can see here after 7 it goes to 5 now. Yes, explicit path option 1 is active now. Now if I trace route, you will see that traffic is going back via 7 to 5 bypassing 6. Right, the ping is happening. The ping is happening via 5 and 7, and then trace route. 7, 5, yeah. Right, hope you understood this. Try doing this once. We'll see the next level of traffic engineering in the next class. Any